Hello everyone, I'm Farhad from ECC section. Today my tech talk topic is about object-oriented programming in Python. Let's first learn what is Python. Python is a wonderful language, but it can be daunting for a newcomer to master. It is also an object-oriented language since its beginning. It allows us to develop applications using an object-oriented approach. An object-oriented pattern is to design the program using classes and objects. The object is related to real-world entities such as book, house, pencil, etc. The OOPS concept focuses on writing the reusable code. It is a widespread technique to develop the problem by creating objects. Principles of object-oriented programming. Class, object, method, inheritance, polymorphism, data abstraction, and encapsulation. Let's have a look at each one of them. First, class. The class can be defined as a collection of objects. It is a logical entity that has some specific attributes and methods. For example, if you have an employee class, then it should contain an attribute and method. That is an email ID, name, age, salary, etc. Here is the syntax of class, and here is the example of a program where we can use class. Let's have a look at the second type, object. The object is an entity that has a state and behavior associated with it. It may be any real world object like a mouse, keyboard, chair, table, pen, etc. Integers, strings, floating point numbers, even arrays and dictionaries are all objects. More specifically, any single integer or any single string is an object. An object consists of state, behavior, identity. State. It is represented by the attributes of an object. It also reflects the properties of an object. Behavior. It is represented by the methods of an object. It also reflects the response of an object to other objects. Identity. It gives a unique name to an object and enables one object to interact with other objects. To understand the state, behavior, and identity, let's take an example of the class dog. The identity can be considered as the name of dog. State or attributes can be considered as the breed, age, or color of the dog. The behavior can be considered as to whether the dog is eating or sleeping. The self. Class methods must have an extra first parameter in the method definition. We don't have to give value for this parameter when we call the method. If we have a method that takes no arguments, then we still have to have one argument. The init method. The init method is similar to constructors in C++ and Java. It is run as soon as an object of a class is instantiated. The method is useful to do any initialization you want to do with your object. Let us now see how to create a class and an object with class and instance attributes. First, let's insert the class attribute. Then, insert the instance attribute. After that, object instantiation. Then let's access the class attributes and instant attributes. And here is the output. Let us talk about the third type, method. In object-oriented programming, we have objects. These objects consist of properties and behavior. Furthermore, properties of the object are defined by attributes and the behavior is defined by using methods. These methods are defined inside a class. These are the reusable piece of code that can be invoked or called at any point in the program. There are basically three types of methods in program. First, the instance method. Second, the class method. Third, the static method. Let's have a look at each one of them. Instance method. The purpose of instance method is to set or get details about instances or objects. That is why they are known as instance methods. They are the most common type of methods used. They have one default parameter, self, which points to an instance of the class. Although we don't have to pass that every time. We can change the name of this parameter, but it's better to stick to the convention itself. Let's see how to create an instance method. First, take the class, then by using init method or the constructor method. Then by writing the sample method, and here is the output. Let's talk about the class method. The class method is an inbuilt function in Python, which returns a class method for a given function. Let's see how to create a program using class method. Let's take the class, then create a variable, and then creating a function. Then print the student's name. And here is the output. Let us see the static method. A static method is a method which is bound to the class and not the object of the class. It can't access or modify the class state. It is present in a class because it makes sense for the method to be present in the class. Let's see how to create a program using static method. Let's just demonstrate the static methods. First, insert a class. Then, use driver's code. Calling the method of class without creating any instance. And here is the output. Let's talk about inheritance. It is the capability of one class to derive or inherit the properties from the other class. The class that derives properties is called the derived class or base class, and the class from which the properties are being derived is called the base class or parent class. The benefits of inheritance are as follows. It represents real-world relationships very well. It provides the reusability of code. We don't have to write the same code again and again. It also provides us to add more features to a class without modifying the class. It is transitive in nature, which means if the class B inherits from another class A, then all subclasses of B would automatically inherit from class A. Let's see how to create an inheritance method. First, let's see how to create a parent class. Create a class named person with a first name and a last name, and then print the name method. Use person's class and then execute the method. And here is the output. Then let's create child class. To create a child class, create a class named student, which will inherit the properties and methods from the person class. Use the student class to create an object and then execute print name method. Let's just add the init function. So far, we have created a child class that inherits the properties and methods from its parent. Now, we want to add the init function to the child class instead of the pass keyword. Let's add the init function to the class student and then add properties. Then let's use the super function. Python also has a super function that will make the child class inherit all the methods and properties from its parent. Then let's add the properties. Add a property called graduation year to the student class. As we are using graduation year. In this example, 2019, the year should be a variable and is passed on to the student class with student subjects. To do so, add another parameter in the init function. Add a year parameter and pass the correct year when creating objects. Let's add another one called method. Add a method called welcome to the student class. Then finally print welcome self.firstname self.lastname to the class of self.graduation year. Let's have a look at the input. First defining a class, then using an init function, then using student, then using method and year. And here is the output. Let us talk about polymorphism. It is the ability of a child class to override a particle attribute from the parent class. This is often the necessity when a parent method doesn't quite fit the needs of the child class. It is achieved by overriding the method in the child class through redefinition. Polymorphism simply means having many forms. Let's take an example. For example, we need to determine if the given species of birds fly or not. Using polymorphism, we can do this using a single function. Let us see polymorphism in built-in function len. The built-in function len calculates the length of an object depending on its type. If the object is a string, it returns the count of characters. And if an object is a list, it returns the count of items in a list. The len method treats an object as per its class type. As we can see in the picture, we have compile time polymorphism, runtime polymorphism. In compile time, we have function overloading, operator overloading, and in runtime polymorphism, we have virtual function. Let's see a program using polymorphism. Let's see the input. Students, by giving 3 names of the students and then their school, we have the output here. In len, we have string which count the characters, list count of items, and dictionary which counts the keys. Let us have a look at encapsulation. Encapsulation is one of the fundamental concepts in object-oriented programming. It describes the idea of wrapping data and the methods that work on data within one unit. This puts restrictions on accessing variables and methods directly and can prevent the accidental modification of the data. To prevent accidental change, an object's variable can only be changed by an object's method. These type of variables are known as private variables. Here is an example. Let's insert the class. Then by using init function, let's insert the self name and the project. By using method, we can print the self name. Let us see the input. Let's just demonstrate the private numbers by first creating a base class. After creating a base class, we should create a derived class. After derived class, we should call the constructor of the base class, then print the private member of the base class, then the driver code. And here is the output. Thank you so much.